these things, and how we are applying this concept of machine vision in factory automation and robotics. So these are the topics we discussed in the previous session. Right. Now, the basic element of the factory automation, if you're giving the feedback, okay, say for example, if you're having a robot like this, the basic element of this robot is for giving feedback, right? We require a sensor, right? The sensor is an element which gives a feedback, right? It converts the total environment into a readable form, and it's giving the feedback to the controller. Then we can use it. Okay. Students, so in this session, we are going to see about the types of the sensors. Okay. Here we are having the difference between the transducer and the sensor. This picture depicts the difference between transducer and sensor, right? It shows this transducer is converts one form of energy to other form, but whereas in sensor, right, it converts the total environment into the readable form or a data, right? It is called the sensor. Then also we discussed about LabVIEW software, and next is how to convert the sensor to the data, and we saw about data acquisition, and we saw about strain gauge, and we gave the practical examination. As actually we gave a simulation through Tinkercad site. It is the strain gauge and how this strain gauge is used to measure the weight, right? So these are the concepts we discussed in my previous session, and we discussed about the difference between transducer and sensor elaborately in my previous session. Okay, and we discussed about stimuli of sensors. We have 6 types of this stimuli. It is acoustic, electrical, magnetic, thermal, mechanical, and optical. We discussed these things too, right? And we saw about some pictures of sensors. It is color sensor, gas sensor, smoke sensor, humidity sensor, gyroscope, touch sensor, IR sensor, PIR sensor. PIR means passive infrared sensor. Okay, so these are the things we discussed in my previous sessions. Thermocouple, next is thermostat, right? Next is LM35. It's a type of temperature sensor. So we can see about these things, and we can use the sensor to give the feedback to the controller. We can use efficiently the sensor to make our robot to do its operations effectively, right? So we discussed about strain gauges also in my previous session, how the strain gauge is used. It is it's like a foil. It's like a foil. Somebody is waiting, please wait. Yeah, it's like a foil, right? We can use the strain gauge to check the weight. If you are giving the force, then its electrical resistivity is going to change. Based on this electrical resistivity, we can measure this electrical resistivity using a multimeter. Then you can check. Then we can convert, or we can calibrate using the strain gauge how we are giving the forces, right? So it is a short recap of my previous session. Okay. Now, can you see the picture what I'm showing? So it is the exact topic what I'm going to start in this day. So in today, shall I start? Can you see the picture what I'm showing?
Yes, sir, visible, sir. Stop.
Okay. Thank you. So this is a photoelectric sensor. Photoelectric sensor. We are having this sensor. It is based on the Doppler effect. Do you know the Doppler effect? Say what is mean by Doppler effect. Did you heard about this Doppler effect in your physics? So actually this total engineering is, there is a derived form of physics, right? Say what is mean by Doppler effect. Did you heard about this Doppler effect? It is a phenomenon. It's a phenomenon invented by the scientist Doppler. Yeah, I will tell guys, see, we are sending the light, right? Wait, I will show a picture also. I will send a light, right? Doppler effect is a phenomena, right? I'm going to send a light or a sound with a rays, right? You will compare. This is called as Doppler effect. It may be light, or it may be a ray, or it may be a sound wave, or whatever may be, right? We are going to compare, or the distance, right? This is coming under the Doppler effect. In the same way, we are sending the signals. Then we are going to receive the signals. Simply, it is a light, right? So we can compare the sent signal and the signal received. Then we can get the position of the object, right? We can sense this object and its distance. This is the principle behind this photoelectric sensor, right? It is the most industrial photoelectric sensor is using the light emitting diode. We are having a LED, small LED. It is a light source. We are giving the transmitter of light, right? Simply we are transisting the light, then we can receive the light, then we'll compare using a comparator, then we can check or we can find the distance of the object, right? See this object, it is in front of the detector. So it is the principle behind this photoelectric sensor. Okay. Now, did you heard and did you saw about this sensor? It is called ultrasonic sensor. Students, have you saw about this? See, what is this? You did several projects in this sensor using Arduino. I hope in your second year also you did several projects. Students, are you there? Shall I continue? Is my sound audible? Okay, is my sound is audible? Okay, okay. Yeah, say answer. Can you see this sensor? Yeah, this is ultrasonic sensor. You can search in internet. This is ultrasonic sensor. Ultrasonic sensor. Search in internet. See, it has a cost of nearly 200 rupees. Okay, so that's all. This is also having the two components, right? We are having transmitter. We are having transmitter and a receiver. Transmitter and a receiver, right? We can give supply, we can give trigger, we can give echo and other things. We have a crystal oscillator also. This crystal oscillator is giving the pulse to this entire unit of the sensor, right? So we can transmit the ultrasonic waves. It is nothing but a sound wave, but we can't hear that sound wave, that's all. So it is called ultrasonic wave. First you should know what is in the ultrasonic wave, okay? Then only you can understand how this sensor works. Okay, see, simple. If you are studying a sensor, then you should know how it works, then where we are going to apply, and all these things you should know. Okay, so we are giving the signal from this transmitter, then we can receive from the other end. So this is a principle behind this ultrasonic sensor, right? So we can send the signal, then it's going to hit an object, then it will reflect. Then that reflected sound wave is received through this receiver. Then we are going to compare this to what we transmitted, then what we received. Then we can comparing means then we can easily calculate, see whether that object is in front of the sensor or not, right? Also we need calibration, right? For the starting of the sensor, we need calibration also. Okay, okay, guys. Hope you can understand what I'm telling about this ultrasonic sensor. Okay. Next is this ultrasonic sensor and this type of photoelectric sensor can be used as a proximity sensor. Say what is meant by proximity? Say what is proximity? Do you have any idea about proximity? What is meant by proximity?
So it senses the light rays and the other things.
Okay. Then according to Google, see, simply you can search for proximity. I will give you a clear picture of proximity, whether this object is coming or not. You can, yeah, please, right? Yes, proximity. You can search whether this object is coming or not. You can search the proximity. So it is called as proximity sensor, right? I will give you see this clear picture, right? If an object is coming towards, then it will sense. Or if an object is crossing, then we can use this proximity sensor. You can see this type of proximity sensor in our thermal engineering laboratory also. It is speed. Simply we can check the speed also. It is proximity sensors. You can check this. It is a picture. You can see in our thermal engineering laboratory to calculate the speed of the flywheel of an engine, right? Using this, we can sense the speed. So this is some type of proximity sensor. We can use to sense the speed, and you can use to sense the distance between an object, similar to this ultrasonic proximity sensor. Okay, so this is some examples we are using in the proximity sensor, right? Next is we are having the capacitive type sensor. So also it is a type. Okay, see this picture. So here you can see the clear picture about the types of proximity sensor. We have 4 types. It is classified. It is based on the sensing range, right? So it is based on the sensing range. It is from 4 mm to 40 mm. We have inductive type, and we have 3 mm to 60 mm. Then we will go for capacitive type. If we have 1 mm, please wait. I will show my pointer options and pin here, right? You can go for this 4 to 40 mm, then we'll go for this type of inductive type. Okay, and next is if we're having a 3 to 60 mm means, then we'll go for this capacitive type. And please, someone is waiting. Keep it. Yes. Okay, I will start my presentation. Okay, then I'm having this 60 mm to 1 mm. Then we can go for photoelectric, right? It's a photoelectric type sensor. So actually, so here I gave a clear explanation about photoelectric, right? Say what is meant by photoelectric and how it works. Students, do you have any idea? Say what is meant by photoelectric. So how it works. See, we are pausing the light. So we are comparing the light, right? We are comparing the transmitted light and our received light, means then this is called photoelectric sensor. Okay. And next is I'm having an eraser. I will erase it. Okay, I'm sorry. And next is here. This is ultrasonic sensor. So actually, I told a type of sensor, and I shown a type of ultrasonic sensor, but it's different. If you're going for an industrial use case, factory, see, if you're going for the factory automation case, then we have a high precise and high accurate type of ultrasonic sensor. So it is a factory, use case type ultrasonic sensor. Here you can see, here you can see the range of 30 mm to 3 mm is the range. You can use this. And we have so many applications. If you are selecting this sensor, then you should aware about its applications. See whether the sensor is suitable or not. Okay, students, can you see the screen now? Shall I continue?
Yes, sir.
Yeah, okay, thank you. Okay, if any close range detections, right, if you're using the ferrous material, then we can go for this type sensors. Say why we are choosing this type of inductive type sensors for this ferrous material? Ferrous material, why? It has a high electrical conductance. So it's a reason, right? Or it may be steel or copper, or it may be aluminum. So it can conduct the electricity easily. So it's a thing we need. Okay, the next is close range detections, means then we go for capacitive type sensors. So you should aware about this, right? And for this you can use liquid, wood, or you can use this granulates or plastics or glass, etc. Right? Here there is no need whether this material conduct electricity or not. So it is a range. Okay. The next is long range, means then you can use this photoelectric sensor. We can transmit the light through the long range of the distance. Here you can see this 60 mm. 60 mm. If you are choosing this correctly, then you can get high precise and high accurate. So it's a reason, right? The next is here we can use this silicon, plastic, paper, metal, etc. Right? So it's a range. Next is we are using this ultrasonic. It is for using to detect the materials of cell phone, foam, glass, liquid. So it is like things, right? We can use for long range detection. Okay, hope you can understand the selection of sensors. See, simple, it is called proximity sensor. We are using this proximity sensor to what? To check whether the object is coming or not, right? So it is the reason behind this. Students, can you able to understand what I am telling? Shall I continue? Okay.
Yes, sir.
Shall I continue? Okay.